to wrap up this week, we are going to start Chapter 9. Actually, we've already done the first part of Chapter 9, but we lumped that in with Chapter 8. So we just called it Chapter 8. But really all the stuff that we learned about the quadratic formula is from Chapter 9. So we're starting really at section 9.2.1 here. And we're going to step away from the book for a little bit and kind of do our own thing with the second half of this chapter. So your notes today are all about what an inequality is and how we can graph the solution to an inequality situation. Okay, and so we're going to keep it really simple today. Quick set of notes, and then your assignment for this week is going to be to get caught up. All right, so if you are up to date and on top of things, great. Listen to this notes video, okay, and fill things out with me or take notes on a separate sheet of paper, and then you're all set for the week. If you're behind it all in algebra, use the rest of this week to get yourself caught up. I will create a separate assignment tab just so that there's something officially posted for Friday, but it will say get yourself caught up this week, okay? So let's talk about what an inequality is. So to start, we're going to be using the number set that's posted there from -3 to +3, written in order. And for each of the following, you're going to state which numbers would be solutions. So for example, out of all of these numbers, okay, which ones would represent numbers that are greater than or equal to a -2? Well, that would mean that the possibilities for x in this number set would be a -2, because we're equal to -2, -1, 0, 1, 2, and 3, okay? And so what I want you to do is pause the video and fill that in for the remaining 5 problems in this top section. And then start the video again and we'll check your work. Okay, so we're back. Let's check our work for the rest of these. All of the x values less than 1 would be x equal to 0, -1, -2, and -3. If x is equal to 3, well, there's only one solution, and it's 3. If x is bigger than or equal to -1 and smaller than 2, then in this set of numbers, the possible x values are -1, 0, 1, and 2. All of the x's bigger than or equal to 0 in this set would be x equal to 0, 1, 2, and 3. And all of the x's less than -3, well, in this set, that's not happening. So we would say there's no solution for this set of numbers, because in this set of numbers that we're working with, none of them are smaller than a -3. Okay, now I want you to think about the entire number line. How many solutions does each of these sets have? So for example, on the entire number line, how many numbers are smaller than 1? Here's 0, here's 1. How many numbers are smaller than 1? Well, that number line goes on and on forever. So technically, there's an infinite amount of numbers that are smaller than -1. Okay, and so we can write out in words what that is. We would say it's all x values from -infinity to 1. Okay, for the second one, x equals 17. Well, there's only one solution, and that's x equals 17. All right. And then for the x values between 5 and 10, well, again, take a look from here. If this is 0, okay, and let's say this is 5 and this is 10, how many numbers are in between both of these, but not including 10? Well, again, there would be an infinite number of solutions. okay? Because there's an infinite amount of numbers between 5 and 10. We're not just talking about 6, 7, 8, and 9. We're also talking about the decimals in between. So there's an infinite amount of solutions for the last one. The middle one has one solution, and the first one has an infinite amount of solutions. Okay, so how do we represent that on a number line? Well, what we do is we start to shade, okay? Almost kind of like I did in this first one here, all right? If we want everything less than or equal to 1, let me switch colors here. We're talking about everything starting at 1 and going back this way, okay? So I have some number lines here that are shaded, and I want to point out a few things to you to help you understand how they represent inequalities, all right? Notice that the first number line has a dot that's filled in, but the second one and the third one have dots that are not filled in, although the third one also has a dot that is filled in. It has both, okay? What does that mean? Well, if the dot is filled in, that means the number is included in the inequality, okay? So for example, in this first one, I've shaded everything bigger than a positive 1, and because I filled in that dot, we're also equal to. So the inequality that's represented here are all of the x values bigger than or equal to a positive 1. And if the circle is not filled in, that means the number is not included. Okay, which means we're strictly less than or strictly greater than. So here, I've got everything shaded that's less than a -3. So my inequality is all of the x values strictly less than a -3. If the dot is filled in, it's included and we're equal to. If it's not filled in, it's not included and we're strictly less than or strictly greater than, okay? So here, the -4 is included, but the +2 is not, okay? Which means at the -4, we're going to have an inequality that's less than or greater than or equal to. We're going to include that equal to part. And for the one on the right, we're going to be strictly less than or strictly greater than. So let's figure this out. Since we're shading everything in between, we're everything greater than or equal to the -4. But since it's to the left of that open circle, we're strictly less than. So we're everything in between here. Our x values are bigger than or equal to the -4, and they're less than the +2. Again, notice, strictly less than, the 2 is not included. And here we're greater than or equal to, the 4 is included. Now that we have a general understanding of what an inequality is and how to represent an inequality on a number line, let's talk about how this applies to algebra. Let's say, for example, we have this inequality, 2x minus 1 is greater than or equal to 3. Okay, looks almost like an equation that we would be used to solving, except instead of an equal sign, we have that inequality symbol, okay? So the first thing I want you to do is pause the video, and I want you to think of some x values that will make this work. And also see if you can figure out the smallest x value that will make it work. Okay, so do some thinking on your own. See if you can figure out a couple x values that will make that a true statement, that will make 2x minus 1 bigger than or equal to 3. And also, can you figure out what the smallest x value would have to be that would make that statement work? So hopefully you were able to come up with some values for x that make this work, okay? One possible value for x that makes this work is 10. Let's try 10. 2 times 10 minus 1. I want to make sure that's greater than or equal to 3. So I have 20 minus 1 greater than or equal to 3. And let's see here. So 19 is bigger than or equal to 3. Yep, true statement. X equals 10 is a number that will work, okay? I'm going to pick a negative number just because. Let's see if that will work, all right? So let's do X is equal to a negative 2. 2 times a negative 2 minus 1, is that greater than or equal to 3? Whoops, I'm running out of room there. So I have a negative 4, take away 1 more, that's a negative 5. That is not a true statement. So that means a negative 2 won't work. And so you can keep picking numbers, positive and negative, and see if you can narrow it down. What you should have found is that the smallest X value that makes it work is X equal to 2. In a minute, I'm going to show you how to figure that out algebraically. But at this point, really, your one strategy is to just keep guessing and checking numbers, okay, until you keep getting closer and closer to the last value that makes it work, all right? Now, when we find the smallest number that makes an inequality work, this becomes our boundary point when we give an answer. So for this particular inequality, if 2 is the boundary point, that means that's where all of our solutions start. And the way that we express the solution in algebra then is to say that the X values that work are all X values bigger than or equal to 2. And the solution on our graph looks like this. If this is 0, here's where 2 is. Since we're bigger than or equal to, I'm going to use a closed dot, okay? And I'll shade everything bigger than or equal to 2. What we really need to learn, though, is how to solve these without guess and check, okay? And so the way that we do that is we first pretend that the inequality is an equation and we find the starting point. So I'm going to start with my inequality and I'm going to rewrite it as an equation. 3 minus 2x is equal to 1. I'm going to solve this equation. I'm going to subtract 3 from both sides. So I have a negative 2x is equal to a negative 2. So I'll rewrite that up here because I ran out of room. And I'm going to divide by a negative 2 on both sides. And so I know x is equal to a positive 1. That is my boundary point, okay? So I know that's an important part of my solution. So if this is 0, the number 1 is an important part of the solution on the number line. Now I'm going to decide if I'm using an open or a closed circle, okay? Take a look back at the original inequality to figure that out. I'm strictly less than, so I'm going to use an open circle. If I was equal to, it would be closed, but since I'm less than, it's going to be open, okay? Now we have to do a test point on either side to see which direction the arrow is going. And what we're looking for is for that test point to make our original inequality true. So the first test point I'm going to do is I'm going to use 0. All right, that's the easiest test point to use. See, think about it as this. Your boundary point splits it into the left side and the right side. Pick a point on the left, pick a point on the right. One of them is going to make a true statement. One of them is going to make a false statement. Go with the true statement. So I'm going to try 0, okay? Test point of x equals 0. I've got 3 minus 2 times 0, and I need that to be less than 1. This is just 0, so I'm left with 3 less than 1. That is false. So that means my solution is probably not over there. But to be sure, I'm going to choose a number on the other side. I'm going to choose 2, okay? Tell you what, I'll put that work right here underneath. X equals 2. 3 minus 2 times 2. I need that to be less than 1. Okay. On the left, I've got 3 minus 4, which is a negative 1. That is less than 1. Winner, winner, chicken dinner. It worked. Okay, so that means I am shading everything to the right. This side was false. This side was true when I did my test point. So I'm shading everything this way, okay? Doesn't always match the original inequality symbol in the original problem. So be open to that, right? This in the original problem, it showed less than, but here I'm shading greater than the 1 for my final solution, okay? Let's try this one more time. Okay, first thing we're going to do is we're going to pretend it's an equation and figure out our boundary point. 3x plus 1 is equal to 7. I'm going to subtract 1 from both sides. 3x is equal to 6. Divide by 3 and x is equal to 2. This is my boundary point. Okay. The second thing I'm going to do is I'm going to decide whether I'm using an open or closed circle. So here's 0, 1, here's 2. I am strictly less than, so again, I'm going to use an open circle at 2. And now I need to do test points, okay? So for test points, I'm going to pick 1 to the left and 1 to the right. I'm going to choose 0, and I'm also going to test 3. If x is equal to 0, I've got 3 times 0 plus 1 is less than 7, which means I'm left with 1 less than 7. That's a true statement, okay? Let's just test 3 to double check my math, make sure I didn't make a mistake. And so I'm taking 3 times 3 plus 1, and I need that to be less than 7. Well, that's not going to work. 9 plus 1 is 10. That is not less than 7. 3 does not work. That's false. So that tells me I'm shading this way. Okay, one of your test points should work out to be true. Now, the last thing we need to do is we need to write the solution algebraically. So that means using an inequality symbol. And so I am going to back up to the last one. I forgot to do that. I'm going to erase this a little bit so I have some room to write. Okay. And so for this one, I shaded values bigger than 1. So my solution is all x values bigger than 1. And for this one, when I want to express my solution algebraically, hang on, let me erase this. If I want to express my solution algebraically, I shaded all the values less than 2, so it's all x values less than 2. All right, so for each of these, we've represented the solution algebraically using inequality symbols and also on a graph by shading on a number line, okay? And that's it for today, all right? So I just want to leave you with that idea this week. And next week, we'll get into practicing using this idea and moving on to how we can graph inequalities on the coordinate plane. As I mentioned before, your work this week is to make sure you are caught up on all of your assignments for me through this week, okay? Which really means, finishing up there was a little check-in quiz after Monday's assignment to make sure you understood the content in the video. All right, so get all your assignments in, make sure you're caught up, and then next week we'll continue on with graphing these inequalities. Have a great rest of your week and enjoy your weekend.